Hello students. So today we are going to discuss about the problems which are based on the self induction and LRDC circuit. Okay. So in the theory part we have discussed all about this. So all of you know about the self induction. Okay. So here problems on self induction. Okay. So when we're discussing about that, so up to problem number 24 we have discussed this. So next problem is problem number 25 and which are based on the self induction. So it is theoretical. So first of all we are in the problem. When the current through the solenoid increases at a constant rate, the induced current will be okay. So induced current is constant but it is in the opposite direction to the inducing current. म्हणजे जो करंट ॲक्च्युअली फ्लो होतोय तर त्या करंटच्या अपोजिट डायरेक्शनमध्ये आपला इंड्युस्ड करंट असणार आहे. ओके. सो ऑप्शन सेकंड इज करेक्ट. ओके. सो नेक्स्ट we will discuss next problem number 26. So for the problem number 26, how we solve this? In that problem, a solenoid of 10 Henry inductance and a 2 ohm resistance is connected to a battery of 10 volt. In how much time the magnetic energy will be reaches to 1/4 of the maximum value. Okay. So first of all we have to write the given data here. So given data is inductance means capital L is given, that is self inductance 10 Henry, H capital H denotation for Henry. Resistance is also given, R is equal to 2 ohm. And after that okay, so we have the relation between the magnetic energy and the self inductance, which is what? U is equal to, or magnetic energy we have denoted by UB is equal to 1/2 Li square. So as we know, hence UB is proportional because inductance is constant. Okay. So UB is proportional to I square. So hence I is proportional to square root of UB. Okay. So there is a relation given between UB and I. Okay. So value of energy is 1/4 of the maximum रीच करत आहे. बरोबर. मग आपण U1 इज इक्वल टू काय म्हणू शकतो? U म्हणू शकतो. ओके. आणि U2 इज इक्वल टू काय? 1/4 of U. Okay. So we have to find the relation between I1 and I2, and after that we have to find the time required for that. So how we solve this problem? Just look here. So it is directly proportional, that's why we take I2 upon I1 is equal to square root of U2 upon U1. Okay, when we put the values we have 1/4 of U upon U. You get cancelled. So I2 upon I1 is equal to, in square root of 1/4. So that is what we have, I2 upon I1 is equal to 1/2. So hence I2 is equal to I1 by 2. Means current reaches its half life value. So we know the half life time. So half life time is equal to what? So T is equal to 0.693 L upon R. So L is 0.693 into 10 upon R. Okay. So R, so it's we have value 2, 10 by 2 means 5, so 5 into 0.693. So when we calculate this, it is around 6 3 point something, means 3.5 second answer is there. Okay, so this is the answer for this problem. So option number first is correct. Then we have to solve the next problem. That is problem number 27. Okay, so first of all we have to clear this. So first of all we have to read the problem number 27. So problem number 27 is what? Just look here. An inductance of coil, the time constant is 4 seconds. So time constant is given 4 seconds. As we know, the time constant having the value is L upon R, as we discussed in the theoretical section. Okay, so we have look here. Problem number 27, given data is equal to, so what we have, lambda is given. Problem number 27, 4 seconds. Okay, if it is cut into 2 equal parts and connected parallel, then new time constant of the circuit is, आता इकडे पहा, लॅम्बडा इज इक्वल टू काय असतं, एल अपॉन आर असतं. ठीक आहे, मग या ज्या वेळेस असेल ही कॉईल असेल त्यावेळेस त्याचा इंडक्टन्स एल असेल आणि रेजिस्टन्स सपोज आर असेल. जर दोन सेम पीसेसमध्ये कट केलं, ठीक आहे, आणि कसं कनेक्ट केलं, पॅरलली, त्यावेळेस त्याचा इंडक्टन्स आणि रेजिस्टन्स इक्वली डिस्ट्रीब्यूट होणार, एल बाय 2 आणि आर बाय 2, आणि या पद्धतीने आपण पॅरलली कनेक्ट करतोय. ठीक आहे, सो याचा पण किती येईल, एल बाय 2 अँड आर बाय 2 इक्वली डिस्ट्रीब्यूट होणार आहे. ठीक आहे, मग आपल्याला माहिती आहे पॅरलल इंडक्शनसाठी पॅरलल कॉम्बिनेशन काय असतं, पॅरलल कॉम्बिनेशन ऑफ इंडक्शन काय असतं, 1 upon LP is equal to 1 upon L1 plus 1 upon L2. ठीक आहे, हे जर सिम्प्लिफाय केलं तर LP is equal to काय येतं, L1 L2 upon L1 plus L2. ठीक आहे, मग LP जो पॅरललचा इक्वॅलंट आहे त्याची व्हॅल्यू काय येईल, चेक करूया आपण. L by 2 into L by 2 upon L by 2 plus L by 2. सॉल्व केलं तर LP is equal to येईल L square by 4 आणि येईल 2L by 2. 2 get cancel, L will get cancel, so LP is equal to L by 4. आणि सिमिलरली रेजिस्टन्सचं पण तेच कॉम्बिनेशन असतं. सो हेन्स R equivalent is equal to also R by 4. ओके, सो मग हे जर पुढे आपण सॉल्व केलं तर पुढे सॉल्व केल्यानंतर आपल्याला टाइम कॉन्स्टंट फाइंड करायचं आहे. ठीक आहे, या केससाठी तर टाइम कॉन्स्टंट काय येईल परत पाहूया आपण. सो फॉर द टाइम कॉन्स्टंट लॅम्बडा इज इक्वल टू एल इक्विवॅलंट अपॉन आर इक्विवॅलंट. सो किती येईल, L by 4 upon R by 4. So 4 get cancel, also L upon R. So time constant remains as it is, means L upon R means 4 seconds. So answer is first 4 seconds remains as it is. Okay. Then problem number 28. Which statement is which statement is correct from the following? Okay. So they ask about the correct statement. So they give many choices here. Inductor store energy in the form of magnetic field. This is correct. Capacitor store energy in the form of electric field. This is also correct. Inductor store energy in the electric and magnetic field both. This is not correct. capacitor stored in energy in the form of electric and magnetic field. This is also wrong. So these two statements are correct. So which option is correct for this? A and B is correct. So first option is correct for this. Okay. So next problem, if the problem number 29. So how we solve the problem number 29? Look here. So first of all we have to write the given data for this. Just look carefully. If a current of 2 ampere is give rise to a magnetic flux. So first of all you write the given data. I is equal to 2 ampere. Magnetic flux I think given phi is equal to 5 into 10 raised to minus 5 Weber per ton. Okay. Then 100 tons. N is equal to 100 tons. So they ask the magnetic energy stored in the medium surrounding by the coil. So magnetic energy UB, as we know, is equal to what? 1/2 Li square. So I is given, but we have to find the L. So for the coil or solenoid coil, we know that N phi is equal to Li. So hence L is equal to what? N phi upon I. So which is equal to what? N is 100, phi 5 into 10 raised to minus 5 upon I is 2. So it becomes 50, 5 into 50, 250 into 10 raised to minus 5, means we have to convert it into 2.5 into 10 raised to minus 3 Henry. So we have to put this value into our formula of magnetic energy. UB is equal to 1/2 Li square. So 1/2 into value of L is 2.5 into 10 raised to minus 3. I square means 2 square is 4. So 2 to get cancel 2. So 2.5 into 2 is 5. 5 into 10 raised to minus 3 joule. Okay. So this is the energy. Third option is correct. Okay. So after this we have to solve the problem number. Next problem is problem number 30. So problem number 30 is what? Just look here. So for the problem number 30, for a solenoid keeping the turn density constant, its length making half and its cross section radius is double, then the inductance of the solenoid increase by. So for the problem number 30, we have the formula for solenoid. Self inductance of solenoid is equal to what? L is equal to mu 0 n square pi r square upon L. Okay. So from this, as we know, mu 0 n square L, because we know that capital N is equal to small n upon L, means number of turns per unit length. So L will get cancelled here, pi r square. So number of turns keeping constant. Okay. And which thing is going to change? Radius is double and length is half. So L is proportional to, capital L is proportional to length and radius square. Okay. So how we find this? Just look here. So L dash upon L is equal to what? r square upon length is half, means L by 2, and radius is double. Then what happen? 2r bracket square. So what we have? Sorry, there is some kind of mistake is happen. Values are put inversely. Just look, here we have L by 2 because it is directly proportional. Here 2r bracket square because radius is double upon L into r square. So what we have? L by 2 into 4r square upon L into r square. R square cancel, L cancel, 2 cancel, 4 cancel. It is 2. So L dash is equal to 2L. So value is double. So as we know, how we find the percentage? So delta L by L into 100 is equal to, how we find? Delta L means what? L dash means 2L minus L upon L into 100 is equal to what? L upon L into 100 cancel, means 100%. Okay, so it is increase 100%. Second option. After this, a constant current I maintained in a solenoid. Which of the following quantities will increase if an iron rod is inserted in the solenoid along its axis? आयन रॉड जर इन्सर्ट केला आयन कोर, ठीक आहे, तर आयन कोर मुळे काय होणार आहे? मॅग्नेटिक फील्ड इन्क्रीज होणार आहे. व्हॉट थिंग इज इन्क्रीज? magnetic field at the center is increased. Okay, and another thing is what? Magnetic flux is also increased because magnetic field is increased. Okay, and when these quantities are increased, self inductance is also increased. Okay, so that's why first option is correct. Okay, after this we have solved problem number 32. So how we solve the problem number 32? The inductance of a solenoid is 5 Henry. Inductance of solenoid is 5 Henry. Okay, means L is given 5 Henry. Then what? Resistance R is given, it becomes 5 ohm, and it's connected to E, means battery of 10 volt, and the time taken by the current to reach value I is equal to 9 by 10th of its maximum I 0. ठीक आहे, आपल्याकडे एक फॉर्म्युला आहे, I is equal to I0 in bracket 1 minus e raised to r by l into t, याला मायनस साइन आहे. ठीक आहे, मग आता या ठिकाणी I दिलेला आहे, किती आहे? 9 by 10th of I0 is equal to I0 1 minus e raised to r ची व्हॅल्यू किती आहे? -5, l किती आहे? 5. ठीक आहे, आणि इथे आपल्याला काय फाइंड करायचं आहे? टाइम फाइंड करायचा आहे, टी फाइंड करायचा आहे. ठीक आहे, सो दिस टी वी हॅव टू फाइंड. दिस इज कॅन्सल, दिस ऑल्सो कॅन्सल. सो e raised to minus, sorry, 1 minus e raised to minus t. Okay, which is equal to 9 by 10. So we have to take to this side and this take to this side. E raised to minus t is equal to 1 minus 9 by 10. So 1 minus 9 by 10 means what? We have to rationalize this. 10 minus 9 upon 10 means 1 upon 10. Okay. So what we have to do here? We have to take log to the base e. So log to the base, when we take the log to the base e, sorry, first of all we have to take reciprocal. So at that time what? E raised to t we have to take, because exponential of e raised to minus t is e raised to t, and is equal to 1 upon 10 means is equal to 10. So what happen next? We have to take log to the base e. So exponential and to the base e cancel. So t is equal to log to the base e 10, and the value of that is 2.3, not 3. So t is equal to what? 2.3 second. So this is the required answer. Okay, I think all of you understood this. Very simple problems are there, but you have to know the formulas, all formulas of this chapter. So for this you have to practice more and more for this. Okay, after this we have seen next problem, that is problem number 33. So in the problem number 33, an LR circuit with a battery is connected at T0, which of the following quantity is not 0 just after the connection? Okay, so for this answer is only EMI induced in the inductor. EMI induced in the inductor is not 0, because when current is going to change just after the connection, at that time the magnetic fields also change, and at that time EMF is also produced. Sorry, EMF is there, so EMF is also produced. So option number 4 is correct. Then problem number 34. So for the problem number 34, what we have, during the 0.1 second current in a coil increase 1 to 1.5 ampere. If inductance of the coil is 60 microhenry, in induced current in external resistance of 600 micro ohm is. So I will solve the problem number 34. As we know, induced EMF is equal to minus L delta I upon delta T. Okay, sorry, delta T. We have the formula this. So from this we have to find the induced EMF. Okay, so first of all what we have to find? Induced EMF, and after that we have to, by Ohm's law, we have find current. Okay, so E is equal to value of L is what? 60 microhenry. 60 into 10 raised to minus 6. Micro means 10 raised to minus 6 into delta I means I2 minus I1. So 1.5 minus 1 upon time changing. How much? 0.1 second. So E is equal to what? E is equal to 60 into 10 raised to minus 6 into 1.5 minus 4, 0.5 upon 0.1. Okay, so we have to simplify this. 60 into 10 raised to minus 6 into 5 into 10 raised to minus 1 upon 1 into 10 raised to minus 1. This is going to cancel. So 5 6 the 7 it is 300 into 10 raised to minus 6. So this is the EMF. Okay, so we know that E is equal to IR. So hence I is equal to E upon R. Okay, this is by Ohm's law. So E is what? 300 into 10 raised to minus 6, and resistance is 600 micro ohm, means 10 raised to minus 6. 10 raised to minus 6 get cancel. 1 half means 0.4 ampere. Answer is correct. Means fourth option is correct. Okay. So if having any difficulty, then ask me. I am online for this lecture. Okay. Then problem number 35. In the problem number 35, at time t is equal to 0, in this diagram, this inductor is short circuited. Means there is a no any current flow. Okay. Or it works as a open circuit. Okay. So we have to solve the problem number 35. In that, we write given data. Okay. So in that, what should we have? In the problem 35, we have find the equivalent resistance. When it works as a open circuit, this resistance is cancelled from this. Okay. So what happen? Only these two are there. Okay, and which are in series. Okay. So I is equal to what? E upon Rs. So E is what? 10. Rs means these are in series. 6 plus 8. Okay. 10 upon 14 means 5 by 7 ampere is answer. So first option is correct. Okay. So problem number 36 we have to solve. So this diagram is given here. In this diagram, just look, as we discuss, these three are in parallel with each other because all terminals look like that. Okay, so for the parallel combination, for parallel combination of inductance, we know that what 1 upon LP, when it is parallel, 1 upon LP is equal to what? 1 upon L1 plus 1 upon L2 plus 1 upon L3. So each having 1 upon L3, each having ohm inductance 3 Henry, 1 upon 3 plus 1 upon 3 plus 1 upon 3. Base is same, 1 plus 1 plus 1 upon 3. 3 upon 3 is equal to 1 Henry. So hence LP is equal to 1 Henry. Sorry. So hence LP is equal to 1 Henry. So this is the answer here. So first option is correct. I think problem number 36 again copied. So we are for going towards next problem number 37. So when we're discussing the problem number 37, in that what should we have? Problem number 37, the time constant of an inductance coil is 2 into 10 raised to minus 3 seconds. Means we have write the given data. So lambda is equal to 2 into 10 raised to minus 3 second, which is L upon R. R is equal to 90 ohm. We join in series, the time constant becomes 2.5 into 10 raised to minus 3. जर हा सिरीज मध्ये जॉईन केला याला तर लॅम्बडा 1 म्हणूया, याला लॅम्बडा 2 इज इक्वल टू किती येतं, याला आपण म्हणूया आर एस. हे किती येतं 0.5 into 10 raised to minus 3 second. the inductance and the resistance of coil are. So as we know, lambda 1 is equal to L upon R and lambda 2 is equal to L upon R plus RS. ठीक आहे. तर मग कशा प्रकारे फाइंड करता येईल आपल्याला? पण जर पाहिलं so lambda 1 into R is equal to L also, and lambda is equal L is equal to lambda 2 into R plus RS. आता हे सिम्प्लिफाय करू शकतो आपण. ठीक आहे. मग आता काय करणार आपण? व्हॅल्यूज दोन्हीच्या लेफ्ट हँड साइड इक्वल आहे, पुट करा. लॅम्बडा 1 किती? 2 into 10 raised to -3 R भेटेल पहिला आपल्याला, इंटू R किती आहे फाइंड करायचं आहे, इज इक्वल टू लॅम्बडा 2 0.5 into 10 raised to -3 R फाइंड करायचा आहे, RS 90 आहे. ठीक आहे. मग हे 10 raised to -3 10 raised to -3 कॅन्सल, 0.5 ने जर डिवाइड केलं तर ते येईल मला वाटतं 4 R is equal to R plus 90. So hence 4R minus R is equal to 90. So 3R is equal to किती येईल? 90. So hence R is equal to 90 upon 3 means 30 ohm येईल. किती येईल? 30 ohm. ठीक आहे. आणि मग आता आपल्याला काय सॉल्व करायचं आहे? फाइंड काय करायचं आहे? L. R भेटलाय. मग आपण पहिल्या याच्याच व्हॅल्यू पुट जर केलं तर व्हॅल्यू काय येईल? लॅम्बडा 1 इज इक्वल टू L अपॉन R. लॅम्बडा 1 किती? 2 into 10 raised to -3 L upon 30. So L is equal to this 30 into 2 into 10 raised to -3 म्हणजेच किती? 60 into 10 raised to -3 हेनरी म्हणजेच किती? 60 मिली हेनरी. ठीक आहे. म्हणजे कोणतं ऑप्शन येतं? 60 मिली हेनरी आणि 30 ओम, थर्ड ऑप्शन. ठीक आहे. आता पुढे जाऊन आपल्याला नेक्स्ट प्रॉब्लेम सॉल्व करायचा आहे. दॅट इज प्रॉब्लेम नंबर 38. व्हॉट इज द प्रॉब्लेम नंबर 38? जस्ट लुक केअरफुली. So the problem number 38 is what? Solenoid with an core as an average radius 38, given R is equal to 50 centimeter, area of cross section is equal to 12 centimeter square. We have to convert 50 into 10 raised to -2 meter, 12 into 10 raised to -4 meter square, and number of turns N is equal to 1200. Ignore the radiation field across the cross section of the toroid, the self inductance of the toroid. Okay, so toroid, for the toroid we know that N is equal, N phi is equal to Li, and what they ask? Self inductance. Okay, so L is equal to N phi upon I. So N VA upon I. Okay, so value of B for toroid as we know, N in bracket mu 0 Ni upon 2 pi R into I. Okay, and into area. So I think I going to cancel. So we have the formula for this, mu 0 N square A upon 2 pi R. ओके, सो जर व्हॅल्यू पुट करून जर तुम्ही कॅल्क्युलेट केलं, सर्व व्हॅल्यू जर पुट केल्या 4 pi into 10 raised to -3. ओके, नंबर ऑफ टर्न्स 1200 bracket square, area 12 into 10 raised to minus 4 upon 2 pi into radius 15 into 10 raised to minus 2. सगळं जर तुम्ही कॅल्क्युलेट केलं तर येणारा आन्सर जो असेल 2.3 मिली हेनरी एवढं येतं, म्हणजे थर्ड ऑप्शन. ठीक आहे. प्रॉब्लेम नंबर 39 या ठिकाणी आपल्याला सॉल्व करायचं आहे. अ सिलेंड्रिकल आयर्न कोर सपोर्ट्स n टन्स इफ करंट I प्रोड्यूस मॅग्नेटिक फ्लक्स फाय अक्रॉस द कोर सेक्शन. द मॅग्नेटिक एनर्जी इज. मग आता मॅग्नेटिक एनर्जी विचारलेली आहे. UP इज इक्वल टू 1/2 LI स्क्वेअर इन टर्म्स ऑफ फाय विचारली आहे. ठीक आहे. आपल्याला माहिती आहे फाय इज इक्वल टू LI. So L is equal to phi upon I will put करूया 1/2 phi upon I into I square. I are going to cancel, so it becomes 1/2 phi into I. So 1/2 phi into I means second option is correct. Okay, so we have to moving towards problem number 40. So for the problem number 40, what should we have? Just look carefully here. Problem number 40, in that they ask about inductance, self-inductance of torque. As we know, N phi is equal to Li. Last one formula we have to use. L is equal to N phi upon I. So NBA upon I. Phi is BA. So N in bracket B is what? Mu 0 Ni upon 2 pi R into I divided by I into A. So I get cancelled. So what we have formula here? Mu 0 N square A upon 2 pi R M, I think. And when we put the value of area, which is mu 0 N square pi R square upon 2 pi Rm. So I think, sorry, this is small r. So pi get cancelled. So what we have? Mu 0 N square small r square upon 2 pi 2 Rm. So option number first is correct. At the initial value of time constant is, as we know, it becomes L upon R. Okay. Next, energy is stored in the choke coil in the form of, choke coil means inductor. So in the inductor, energy stored in the form of magnetic field, as we know. Okay. Then after that we have solved the next problem, problem number 43. So what is the problem number 43? In the problem number 43, given is when current changes from 2 ampere to 4 ampere in a 4.05 second in a coil, and this the self inductance of coil. Okay, so they ask about the self inductance of the coil. We have the formula. E is equal to minus L delta I upon delta T. Okay, so we have to find the L. L is equal to E upon minus delta I upon delta T. Okay, so we have the all the values. E is what? 8 upon delta means 4 minus 2 upon time 0.05, it goes to upward to numerator. So 8 into 0.05 upon 2, so 4. So the inductance is 4 5 the 20, 0.20, okay, minus sign, so 0.2 Henry, it's having negative sign, and inductance is only positive, so it becomes 0.2 Henry. So this is the final answer. So answer becomes second option. Then we have solved the problem number 44. So we solve the problem number 44. Just look here. For the problem number 44, EMF of 212 volt is given, means di by dt is given, or delta I by delta t is given 48 ampere per minute. So we have to convert it into second. 48 upon 60 second. So how we solve this? Just look carefully. So E is equal to minus L di by dt. So L is equal to E upon di by dt. So L is equal to 12 upon 48 upon 60. Okay, so it goes to upward. T is equal to 12 into 60 upon 48. So 12 ones are, and 12 fours are 48. So 4 ones are 4, 4 15s are 60. 50. So time, sorry, not time, inductance is 15 Henry. Okay, so I think answer is 15 Henry. Then next, number 45. So 45 is theoretical. Two conducting coils are placed coaxial in each other in one coil, then they will, there is a same kind of current is formed, so that's why they repel each other. Okay, then for the opposite current is formed, so that's why they repel each other. For the problem number 46, a coil of resistance 10 ohm and inductance Henry 5 Henry is connected to a battery of EMF 100 volt, and the energy stored in the coil is, so I think L and R is given E. So we have to find the current first. E is equal to IR. So I is equal to E by R. So E is what? 100 upon 10 means 10 ampere. So UB is equal to 1 half Li square. So 1 half into L is 5 into square of 10 is 100. It becomes 50. 55 is a 250 joule. So answer is 250 joule. Okay, so the energy density in the magnetic field B is proportional to, so we know the formula for energy density. So formula is, sorry for disturbance. Okay, so answer is there. So here the answer of problem number 47. We have know the formula for this. So from the formula, it is proportional to B square. We have to solve the formula for energy density, magnetic energy density, for the problem number 48. So for the problem number 48, we solve. L is given 3 Henry, N is given 500, then number of turns is double, then the value of self inductance becomes. मग आता सोलेनॉइडचं सेल्फ इंडक्टन्स साठी जर पाहायला गेलं तर ते कशाला डायरेक्टली प्रोपोर्शनल येतं. इंडक्टन्सचा फॉर्म्युला काय आहे, म्यू 0 n square a upon L. So this capital L is proportional to n square. So I find L2 upon L1 is equal to n2 upon n1 bracket square. So hence L2 upon L1 is equal to 2n upon n square. Okay, so I think n is cancel. L2 is equal to what? L into 4. So 3 into 4 is 12 Henry. So answer is number 4. Okay, so we have to solve the problem next. Problem number 49. Given is L is equal to 40 Henry in series with resistance R of 8 ohm, and the combination is joined to the terminal of battery 2 volt, the time constant of the circuit. Okay, so as we know, the time constant of circuit is what? Lambda is equal to L upon R. So it becomes 40 upon 8, means I think 5 second. Very simple. Number 4. Then problem number 50. When the current in the coil is reduces to 2 ampere to 1 ampere in 1 millisecond, then the induced EMF is 5 volt, the inductance of the coil. So problem number 50. E is equal to minus L delta I upon delta T, hence L is equal to E upon delta I upon delta T. So E is what? 5 upon delta means delta I means 2 minus 1 is 1 into 10 raised to minus 3. So this goes to upward. 5 into 2 into 10 raised to minus 3 upon 1. 5 to the 10. 10 into 10 raised to minus 3 means 10 raised to minus 2 Henry. Sorry, something is wrong. Sorry, this is the value 1. Means 5 into 10 raised to minus 2 Henry. Sorry, this is minus 3. Okay, so 5 millihenry is answer is correct. Option 3rd. Okay, so problem number 25 to 50, all doubts are clear. So all student, I have request that to keep in touch with all teachers. Okay, जर तुम्ही संपर्कात राहिलात तर त्या पद्धतीने आपल्याला आता काम करता येईल. कारण सध्या तरी अजून 1-2 महिने कॉलेज चालू होण्याची कंडिशन दिसत नाही आहे, तर सर्वांनी त्या पद्धतीने टचमध्ये राहून जे चॅप्टर्स होत आहेत त्याचे प्रॉब्लेम्स वगैरे सॉल्व्ह करून घ्यायचे प्रयत्न करायचे. ओके, प्रत्येकाने सेंड करायचं आहे. आता 1-2-3 दिवसात आपले देखील फिजिक्सचे ऑनलाईन लेक्चर चालू होतील, तर तुम्ही पण त्या ठिकाणी एका सब्जेक्टकडे लक्ष न देता सगळ्या सब्जेक्टच्या टीचर्सला आणि सगळ्यांना सहकार्य करायचं आहे, जेणेकरून आपल्याला चांगलं काम करायला होईल. धन्यवाद.